Let's see, looks like it works. Isn't it great to be back in person? Isn't it awesome? Thank you so much for being here in person, being able to see each other, talk to one another, look each other in the eye. It's just so much powerful. I want to start thanking my two co-authors on this work, Dan Cook and Michael Dickey. Dan did in his PhD work, he developed the box test. He developed the float test that I'm going to talk about today. And Michael Dickey, he's worked on a lot of the really cool stuff that I'm going to show you today, how to apply the float test. And also big thanks to Oklahoma DOT and Oklahoma Transportation Center for making this research possible. Now I'm going to talk about the why. I'm going to talk about how to measure vibration, how to measure finishing, and then what can we do with this? So let's jump right in. I like to ask this question to my students. I like to ask this question to practitioners. There's four things listed on the slide. I say, what is the most important? Workability, durability, economy, and strength. Now we're in a workability session, right? So that might hedge off, but workability is the most important. By far, because if you don't have workability, you are not going to get durable concrete with massive voids, massive cracks, massive things inside. You will not get economic concrete. You're going to have to rip it out and put it back in. And that's the least economic concrete there ever is. And then you will not get strength because air is not very strong. So every single project has different requirements, but if you don't have workability, you have nothing. And when it comes to how to design concrete mixtures for workability, I think this is a new mindset, a new focus that we need to have as an industry. The slump test was great in 1911. Pavements, one of my heroes for coming up with it. We can do better than 1911 technology, right? We need to start thinking about how does slip forming, truck place, pump, flat work, et cetera, work, and design mixtures or design test methods that give us some idea about that. Now, we have plenty of people that are been doing it for a long time. They're extremely experienced, and they can look at a mix and say, that'll pump, that'll pave, that'll whatever. That's amazing. That's awesome. But wouldn't it be great to have a scientific test where we can quantify, compare, see, measure, see what's going on? So we all know that there are three different levers that we can typically pull. We can change our paste content, our water to binder. We can pull our admixture level. We can pull our aggregate level. But how do we know which one? How do we know how much? How do we know? That's what I'm going to talk about at the beginning to help you with some of this. So again, we've been working on coming up with tests that are look at how do you place it, drag it, pump it, vibrate it, finish it, do all the workability practice we do. And we'll start out with pumping or with paving because that's what this session is all about. How do we know if we can take a mix that looks something like this before the paver and after the paver turns something to be like this? Now, the goal here is we want a window of workability. We don't want it to be too workable because if it is, it won't hold an edge. We don't want it to be too stiff or it won't respond to vibration. We want the middle. And we also want it to be able to finish. I mean, this is amazing. We can take people off the back of your crew and have them work in other parts of the job because by touching the concrete, you're ruining the ride. That's what you can get when you dial these things in. That's possible to focus on. But if you look inside the slip form paver, what it's all about, what it's doing, the vibrator is doing a lot of the work, important work, consolidating the concrete. We need to understand how that concrete responds to vibration. So we want a test that's simple because if it's complicated, it won't work. No one's going to use it, right? It's got to be extremely simple. It needs to measure their response to vibration. It needs to look at the filling ability of the grout. It needs to look at the ability to hold this edge, this window of workability. And the slump test was cool and all, but it didn't tell us about all this stuff at all. So we came up with a box test. Boy, I think it was 14 years ago when I was doing a project for TxDOT, and I was sitting in my shower, and I was like, the goal was to use the lowest cement possible, and I was shaking in my boots. Because how are we going to come up with a really low slump mix that can really pave? You know, like a really low cement mix that can really pave. We said, what if we did something like this? What if we mimicked the response to vibration? What if we used a 12-inch by 12-inch by 12-inch box that are held together by these pipe clamps? These are two L's, open top, open bottom, held together by pipe clamps. The pipe clamps used to be $20. I think they're about 35 these days, right? Everything's going up in the world. Still not a very expensive test. Very, very simple test that you can run. And this is an Astro test, and I think it's going to become a full standard now, which is awesome. But you add 9.5 inches of unconsolidated concrete to the box. You take a 1-inch Stinger vibrator. You turn it on. You count to 3 as it goes down. You count to 3 as it goes out. Now, how did that come to play? Well, we actually did a bunch of math to say how much energy can I put into that box to match a typical paver at a typical frequency at a typical speed, and that's the same amount of energy. And we immediately take the pipe clamps off, pull the edges off, and we look for honeycombing and we look for edge slumping. You're like, okay, let's see pictures. Looks like this. There's the box. There's a vibrator going in, and you can hear it. Whoa, my gosh! You can see around the outside that concrete has gone from not so consolidated to consolidated. Okay, we're measuring the sphere of influence of the vibrator head. That's what we're doing in the lab, right? Very, very simple, very, very easy to do. And what goes on if you don't consolidate the concrete, once you take it off, you'll see honeycombing. So you take the things off, you immediately pull the edges off, and it looks like that. Like the concrete box of concrete brownie, call it whatever you want to call it. That's what I call it. And we're looking for honeycombing, and we're looking for edge slumping. So we use a visual ranking. Why do we use visual ranking? Because it's simple and it's easy. And you can see with your eye, we're looking for something like around a 10 to 30% overall surface voids, but you can go around and take pictures. You can go around, look at each side, come up with an average ranking for that box. You also look for edge slumping. You say, is it edge slumping at the bottom? Is it edge slumping at the top? Because again, we want that window of workability with our concrete. So here's some examples of one with no edge slump on the left, edge slump on the right. You can see the top coming over, up, either too much paste, too much water reducer, too much something in that mix on the right. We got to back it off. We got to get it right. So in summary, the box test looks at this window of workability. That's why it's powerful. It's helpful when you're designing mixtures in the lab, when you're trial batching in the field, when you're troubleshooting, when you're measuring variation. It's like having a miniature paver. It's pretty sweet. You can take it around with you. Let's talk about the float test next. So great. Response to vibration is awesome. How does it finish? Now this test will work on paving. This test will work on flowable. This test will work on whatever you want. Okay, the last test was just for slip form paving concrete or slip forming in general, barrier wall. Box test is also helpful for that as well. How does the concrete respond to finishing? So we're gonna take some simple forms, 3 foot by 2 foot by 3 inches deep. We're going to fill them full of concrete. We're going to strike it off. We don't saw it. You strike it off the top. You have to make sure it's full. Strike it off. Then you come back and you create 3 1-inch diameter and 1-inch deep holes. Why do we do that? Well, oftentimes in the field, when you strike concrete off, you will pluck out coarse aggregate. It is the finisher's job to fill those aggregate holes in. And we want to know, how hard is it to finish the concrete to make a smooth surface, but also finish in those voids. We're going to move a bull float over at a fixed angle and at a constant speed. We're going to put these, and we're going to measure the number of passes does it take to fill in the holes and create a smooth finish. So that's cool and all. Let's look at pictures. Okay, there it is. There's the concrete in the forms, right? Place and finish. There we go, where we take our template, where we create our 3 1-inch diameter holes, again, simulating coarse aggregate being plucked out. And now we're going to measure, we're going to actually start to run the test. So we have a yoke there. See that yoke there? So we fixed angle. We have trimmed the float so it only rides on the concrete, does not ride on the forms, right? And then you go back and forth. You say, how many times back and forth does it take to create a smooth surface? Now, we don't measure the edges. We just measure the dead center. You might ask, how in the world, Tyler, do you move at a constant speed? Well, thanks for asking that question. We actually make little marks on the side, and the person running the test wears headphones. They have a drum machine going, click track. It's going at a constant speed. And they know every time the beat hits, they hit a line going forward. And every time the beat hits, they hit a line going back. That's how a human very easily can run things at a constant speed. Remember, we're simple people. We do simple things, right? And you might say, well, why do we do that? Well, because we're freaks, right? And we want everything to be as constant as we possibly can in the test. Let's look at some examples. Here is 0 passes on the left. There is 2 passes and 4 passes. You can see the holes closing up. Again, 6 passes is kind of the breakover line between, if it's below 6, that is some really easy to finish concrete. This does not correlate the number of passes in the field, does not. But if it's less than 6, it's going to be pretty easy to finish. If it's less than 10, it's moderate, and then above there. And then here we go. Here's when we look at actual surface texture. And again, we're not looking for perfection. We can deal with some surface voids. 10 to 30% overall surface texture is okay and ready to go. So let's apply this bad boy. Let's use this to answer an important question. Has anyone ever wondered how fibers impact the finishability of concrete? Has anyone ever wondered that? There's all these different fibers out there, right? So, I mean, I'm showing 5 different ones, different types, different whatever. What if we could measure that? Well, oh man, it's coming your way. All the concrete mixtures I'm about to show you have the exact same everything, except for different types of fibers and different dosages of fibers. Water reducer dosage is the same. Water cement ratio is the same. Gradations are the same. Everything's the same, but we're changing the fibers. And we're going to use the float test to to actually compare performance. Here is one product, 4 pounds per cubic yard of a macro synthetic fiber. On the far left here, there's 0 passes. There's 4 passes to the right, and there's 7 passes over there on the far right. Now, is it perfection? No, you could probably get a little bit more, but we don't need perfection. We don't need perfection. We're trying to get a relative test to one another. That's 4 pounds per cubic yard. That's a fairly low dose. Let's go up to 8 pounds per cubic yard, which is much more common. There's 0 passes, there's 4 passes, and then there's 10 passes. Notice 10 is more than 7. You guys got that, right? 10 is more than 7. So that means it took more effort. That makes sense, right? Now let's go up to 12 pounds per cubic yard. Here's 0 passes, there's 4 passes. Now who in their right mind would specify 12 pounds per cubic yard? Oh, I see it. I see it on jobs. Maybe not 12, but I see very high amounts of fibers on jobs. And it's a person that doesn't understand finishing is a person that does that. What if it would be cool to have a test that could show them and compare and evaluate different products out there and how they finish? Now, one cool thing about this is we could do this for all different types of fibers. So I know there's a lot going on this slide, and I don't even know how to make the mouse appear up here. So I'm just going to dance around and point. On the far left, the black bars with no fibers in it at all. 0 fibers in it. You can see it took around 6 passes for that mix, and you have a green line that goes all the way to the right. And then these are different types of fibers that are out there, all right? And then there's a low dose, a medium dose, and a high dose. And hopefully you can see as you go from the low dose to the medium dose, typically the number goes up. The number of passes required goes up. Makes sense, right? Makes sense. And then if it gets above this pour line, that gets really bad. And some of these are so bad they would not finish. I mean, wouldn't finish. As you go back and forth, you would tear the surface open again and again and again. It's a problem. So you need to be able to control these things. Now, what can we say? As fiber dosage increased, finishability typically decreased. But we can also say that with not all fibers finish the same. Some of these, like let's pick out this MC4, even here at 8 pounds per cubic yard, did great. Some of these just straight M4 actually required would be poor. People would cuss. Oh, I'm not supposed to say that in ACI, right? Oh, the cuss words are bad. I can say cuss. Okay, never mind. But usually at 4 pounds per cubic yard, the lowest dosage, all the products looked at performed pretty well, except for one steel fiber, right? One steel fiber did not, right? And we could talk more if you want to talk about what fibers are good or not, and we'll go from there. The flows test is a useful tool to use in the trial batch to ensure mixtures are workable. 4 pounds per cubic yard or 33 pounds per cubic yard of 4 pounds per cubic yard of macrosynthetic or 33 pounds per cubic yard of steel is typically a safe volume to allow fibers to be finished. Higher dosages are challenging, but they can be done. I do want to make a plug for the tarantula curve. That slide looks a little bit weird. We used these 2 tools and a lot of other tools to actually look at 650 different concrete mixtures, a lot of different coarse aggregates, fine aggregates, and people have like mentioned it. We've looked at slip form paving all the way up to flowable concrete, and we looked at all kinds of stuff: gradations, paste contents, water cement ratios, water reducers, and we can summarize more than $1.5 million of research with this, the tarantula curve. Okay, this, and I think other people will be talking about it, but this is your combined gradation curve. Your sieve analysis is down here at the bottom. And then there is a coarse sand check and a fine sand check. People often leave those out. Those are really, really important checks where you want to be. I hope you know something about the tarantula curve, heard about the tarantula curve. If not, I'll give you some free resources coming up about that. But how else are we using these tools? Well, we have redesigned the tarantula curve for manufactured sands. That is pretty cool. We have looked at benefits of larger aggregates like 1.5, 2-inch stone. I mean, are there benefits? Is it worth it? We've quantified that, looked at that. We're doing mixture designs for air-filled pavements right now, which is exciting. Low slump overlay stuff, and we're working on a total mixture design tool. I mean, everything for paste, water cement ratio, all based on your aggregates. So stay tuned for more stuff coming. There's also new tools coming out, things like the vibrating sled. This is for air-filled pavement stuff, all right? So you could do like a strip where this is like a single hydraulic vibrator that you would run through, and you can measure edge slumping, you can measure mortar buildup on the sides. And ladies and gentlemen, we are so blessed that we have our own concrete paver at Oklahoma State University, all right? So we can do some big stuff with this, really see what's going on. So really see what works. And if you want to learn about more what I talked about, you can go to tarantularcurve.com. There's free websites, there's reports there's whatever. You can go to my tylerlade.com/tarantula videos. I've got example problems. I got free spreadsheets. I got all kinds of stuff up there. So in conclusion, the box test and float test, they're crazy useful tools to evaluate the workability of concrete for pavement applications. And these tests give you important insights to help you design your concrete mixtures. And they can be used in the lab to design mixtures or troubleshoot problems in the field. So in closing, that's my email address. That's how to contact me. I don't know if you know this or not, but I got a YouTube channel, got about like 87,000 subscribers now. So if you're not a subscriber, please subscribe, like, leave me a comment. And thank you so much for your time. It's such a pleasure to be back in person. Take care, everybody. If you have any questions, I'll answer them.